Wellworth Products, your premier product supplier, presents the following video on today's fuels, specifically ethanol blended gasoline. During this presentation, we will touch on the recent history of gasoline and the challenges that ethanol blends present. In the early 1990s, fuel suppliers were mandated to add a number of components to fuel. One such component was an oxygenate, a product that releases oxygen when the fuel mixture is burned. Additional oxygen is added in order to aid in the operation of emission control components without decreasing fuel economy. The oxygenate that was most widely used was methyl tertiary butyl ether, or M.T.B.E. It proved to be an effective oxygenate with little or no negative side effects. Unfortunately, M.T.B.E. was found to be a carcinogen, and fuel companies began removing it from fuel around 2004. Ethanol was chosen as the replacement oxygenate. In addition to being effective as an oxygenate, ethanol is a renewable resource and therefore carries a green image. Ethanol also increases the octane of fuel, which allows fuel manufacturers to produce gasoline with a lower baseline octane rating. The transition to ethanol fuel has created some unique problems. Because ethanol is hygroscopic, water that had naturally formed in fuel storage tanks and accumulated on the bottom was absorbed into the fuel and disappeared. In addition, deposits that had accumulated on the surface of the tanks were dissolved and suspended in the fuel. This led to the plugging of pump filters. This same problem occurs in vehicle fuel systems the first time ethanol is introduced, also leading to filter and component plugging. The demonstration you see shows fuel being tested using an ethanol testing device. The fuel tested has an ethanol level of 10%, which is the current level in most fuels sold in North America. Water is slowly added to the E10 gasoline until it is visible at the bottom of the container. The mixture is then agitated, causing the water to enter the gasoline-ethanol mixture where it tightly bonds to the ethanol. This water-ethanol mixture then falls to the bottom of the container. This illustrates the phenomenon known as phase separation. When retesting the fuel at the top of the container, the ethanol level is now down to 3%. The heavy concentration of ethanol and water at the bottom of the container will be the first fuel drawn by most fuel systems. It will allow most engines to run, however, it will burn poorly, resulting in low power and heavy deposit growth. The heavy deposits and the poor burning mixture leads to excessive oil contamination and ultimately to premature emissions component failure. Engine oil is literally vaporized and sent through the crankcase ventilation system and burned in the engine, creating even more combustion chamber deposits. The burning oil also fouls oxygen sensors and catalytic converters. When burned, the phase-separated mixture releases greater than expected levels of oxygen that confuse modern engine management systems and lead to false trouble codes for lean conditions, mass air sensors, and intake air temperature sensors, just to name a few. Phase separation will occur when the moisture level rises or when the temperature of the fuel drops. The water-ethanol mixture is also especially hard on fuel tank pumps, which rely on the fuel for lubrication. This mixture provides no lubrication and is in fact corrosive to many materials commonly found in fuel systems. After the water-ethanol mixture is expended, the fuel remaining is octane deficient, leading to even more drivability issues. The fuel sample shown here is removed from the vehicle which had severe running problems. It clearly shows the octane-deficient fuel at the top and the phase-separated corrosive mixture at the bottom that also contains rust and contaminants from the fuel system. The cut-open section of the fuel line from this vehicle shows the damage caused by the corrosive mixture. The images shown here illustrate the severe damage that can occur from phase-separated fuel. The running problems cause the vehicle to backfire and the plastic intake manifold to fracture. The intake valve shown has severe deposits as a result of burning ethanol-laden and phase-separated fuels. Valve deposits such as these lead to drivability issues ranging from cold start and stall to low RPM misfires. These deposits are even more troublesome in direct injected engines. In this demonstration, we once again start with E10 gasoline, which we add water to and phase separate. The water-ethanol mixture is clearly visible at the bottom of the container. When checked for the presence of water with standard water-finding paste, no indication of water is shown. Next, the mixture is checked with specially formulated paste that is designed to identify phase separation. The color change at the bottom quickly identifies this mixture. Finally, Wellworth Products Fuel Fix RX is added and agitated. The water-ethanol mixture is bonded back into the fuel where it can safely burn with the fuel. Although many products on the market today claim to be formulated to be effective with ethanol fuels, none of these are able to reincorporate the phase separation mixture like Wellworth products.